Welcome students, my name is Nagma. I am PGT Chemistry in Syed Hamid Senior Secondary School. Today the topic we deal with is Markovnikov rule. But before we understand the concept of Markovnikov rule, we need to understand what is the meaning of addition reaction, what is the meaning of electrophilic addition reaction. Now see, alkenes are characterized by the presence of one pi bond and one sigma bond. Double bond contains one pi bond and one sigma bond. The pi bond present in the alkene is weak bond, but the sigma bond is a strong bond. That is why alkenes are considered to be electron rich compounds because of the presence of the pi bond, and that is why it undergo addition reaction. Addition reaction means that instead of one pi bond, two new sigma bond is formed. Two new sigma bonds are formed instead of one pi bond. Now, those addition reactions which are initiated by electrophile, are called electrophilic addition reactions. Electrophiles are electron deficient species, that is why they attack on electron rich compound like alkenes, alkynes, aromatic compounds. Okay. So, I have shown here that this is the molecule of alkene, and in this addition reaction, which is called as trans addition, instead of one pi bond, two new sigma bonds are formed. This pi bond is replaced by two new sigma bond. This is an example of addition reaction, and when this addition reaction is initiated by electrophile, it will be called as electrophilic addition reaction. Okay. Now, second aspect of this topic is addition of unsymmetrical reagent to alkene. Addition of unsymmetrical reagent means unsymmetrical reagent can be any hydrogen halide, unsymmetrical reagent can be water in which the constituent particles, the constituent atoms are different. That is called as unsymmetrical reagent. When we add any unsymmetrical reagent to alkene, there are two cases. In first case, this is symmetrical alkene. Here I have added this hydrogen iodide, which is an unsymmetrical alkene, to ethene. Now, ethene is symmetrical alkene because here the number of carbon atoms and the number of hydrogen atoms are similar. That is symmetrical alkene. Now, when any unsymmetrical reagent added to any symmetrical alkene, here on one atom hydrogen goes and on other atom the other part goes, leading to the formation of one product. The product is 1-iodoethane. Now, this is the major product produced in 100% yield. So, there is no confusion regarding the formation of the product when we add unsymmetrical reagent to symmetrical alkene. But when we add unsymmetrical reagent to any unsymmetrical alkene, here I am adding hydrogen bromide to propene. Propene is unsymmetrical alkene because here the number of carbon atoms and the number of hydrogen atoms on both sides of double bond are different. This is unsymmetrical alkene. So, when we add any unsymmetrical reagent to any unsymmetrical alkene, what happens, students? There is possibility of formation of more than one product. See, here one bromopropane and two bromopropane. What happens actually? What is the case? In one case, if hydrogen atom goes to this first carbon and bromide atom goes to this second carbon, leading to the formation of two bromopropane. And on other case, what is the other case? If hydrogen atom goes to middle carbon and bromide anion goes to the first carbon, then leading to the formation of 1-bromopropane. So, which product is the major product? Which product will form in 100% yield? To rule out this confusion, to clear out this confusion, Viktor Markovnikov, a Russian chemist, he gave an empirical rule which is named after his name, that is known as Markovnikov rule. He postulated this rule. He has given this rule, Markovnikov rule, just to clear out the confusion that if there is a possibility of addition reaction of unsymmetrical reagent to unsymmetrical alkene, which product will form in major yield. Now, what is the statement of this rule? Statement of this rule is, when unsymmetrical reagent such as hydrogen halide, water is added to unsymmetrical alkene in such a way that the negative part of the addendum, what is the negative part here, students? Negative part is Br minus, all of us know that. The negative part of the addendum, addendum means adding molecule, bromide is adding molecule. So, the negative part of the addendum goes to that carbon atom of the double bond which carries lesser number of hydrogen atom, So, according to this rule, which product should be in major yield? A bromide ion going to that double bonded carbon which is having lesser number of hydrogen. So, it should be carbon number 2, and since this is electrophilic addition reaction, it will be initiated by hydrogen followed by the addition of Br minus. So, which product will produce in major yield? It is 2-bromopropane. 2-bromopropane will produce in major yield, it is the major product, while 1-bromopropane will be the minor product. This was the rule which was given by Markovnikov, which is called as Markovnikov rule. So, what is the mechanism behind, from where this rule comes? So, in organic chemistry, we always say that more stable intermediate forms major product. More stable intermediate forms major product. That is the rule. So, we need to understand what is the intermediate, we need to understand what is the mechanism behind. So, it is very easy because we know the concept. It is electrophilic addition reaction, and when electrophilic addition reaction we are talking about, so again I am writing propene, and here electrophile is out of HBr, it is H plus. So, electrophile, either it will go to carbon number 2, yes, either it will go to carbon number 2, carbon number 1 and carbon number 2, or it will go to the other carbon. I am writing, if it is going to carbon number 1, what will be the intermediate? Intermediate will be this. And if it is going to carbon number 2, then what will be the intermediate? Intermediate will be this. Now, can you tell me the degree of this intermediate? Yes, this is secondary carbocation, while it is primary carbocation. This is secondary carbocation which occurs when H plus moves to carbon number first, and this is primary carbocation which occurs when H plus added to carbon number 2. So can you tell me which carbocation is more stable? Yes, order of stability of carbocation is tertiary, followed by secondary, followed by primary, and last methyl carbocation. This is the order of stability of carbocation. So when we say that this is the order of stability of carbocation, which carbocation is more stable? Secondary carbocation is more stable, and as I told you, more stable intermediate forms major product. So this more stable intermediate will form major product, and that is why we say last that more stable intermediate is this. The negative part of the addendum will move to that carbon atom which is having lesser number of hydrogen atom, resulting into the formation of major product, that is 2-bromopropane. The rule says that 2-bromopropane is the major product. The mechanism says that 2-bromopropane is the major product. Both statement and mechanism, they rule out this difficulty, this confusion that if there is possibility of more than one product, which product is major product. So only that product will be major product in which negative part will move to that carbon atom which is having lesser number of hydrogen. So this is all about Markovnikov rule. Thank you.